Yo, just wait for Mahir and Vic.
Bro,
Yeah.
is one full body workout a week enough?
To maintain muscle, I guess.
Bro, I have no time to go to the gym, man.
Small sacrifice.
Mm.
But I think one is more than enough. Like,
What?
like
Oh,
for right now, yeah. Mechanics for oh
there's no projectile on the exam.
there's a projectile? Yeah, but like I might as well cover it now, right? Before
Yeah, yeah.
yeah.
Is this the hardest topic in mechanics?
Like mm, yes, but because there's like just so much like I don't know. They can make it very hard. You get me? Like the
Hmm.
concept is just, you know how you have like 2D like you have vertical and horizontal resistance, right? And how in mechanics too, we treat them differently. Like I had one
Mm,
question where I throw a ball up in the air, and I have one question where I push it forward, right?
mm.
Now in this case, you have I have resistance acting both downwards and across. You feel me? So it can get a bit like messy with very hard questions, but the simple ones are pretty fine. Yeah.
Are you going to 24 July?
Huh?
Are you going to 24 July?
How do you know about it?
Bro, I'm on the account, bro.
Oh no, of course, bro. I'm going. Of course.
Bro, what is this? This is so ass the marketing.
It's um, it's more marketing than anyone's ever done, bro.
Wait, is it just like a normal party?
It's gonna be like ticketed and stuff, like proper venue, Shark Hotel.
Wait, is it like an actual party? I thought it was just like a joke.
No,
Bro,
it's
initially I didn't know it was a party. I thought it was like a music thing.
no,
Like
no,
I,
no, no.
I thought it was like up and coming artists, like Isaac
No, no,
Spiro.
no. It's his birthday. It's his birthday.
Oh shit.
I'm gonna text his mom again to see where Mahir is.
Oh shit. 24th July. Bro, it's so funny. But, mm, me and Oren are pulling up.
Hell no, bro. I'm banning all of you.
No, bro, we're pulling up.
This party's gonna have like, bro. This guy, people are not making it out of it alive, bro. Like,
Yeah, I know. That's what, bro. Right before trials, I need to be fucked up, bro. Like a one day, you know?
uh,
I've heard crazy things about this guy, like drugs and shit.
mhm.
Yeah, yeah. He's like notorious in the Tamil community.
He's he's very notorious, bro. Very
I
notorious,
see, bro. All my Tamil friends are following the account.
bro.
It's,
Broski, what is my here? So I think Vic's like pretty sick.
Bro, it's online tutoring.
Yeah, he's a fever, like a bad one. So I don't know.
Bro.
Hmm.
I look you need to go at like exactly 6:30.
Okay, yeah. Let's see where they are. Like, give it a minute. You know what? I'll get started. We'll just do a sort of yeah. No, we'll just start. Okay. Let me share my screen. Yeah, let's like go through all the questions. So it's like a bit more of a quicker lesson, but also more worthwhile looking at when you look at it online. So we have a cricketer hits a ball from ground level with speed 20 meters per second and angle alpha to the horizontal towards a wall 20 meters away. Take G to be 10 meters per second squared and the origin at the point the ball is struck. Show that the ball hits the wall at height h equals 20 tan theta alpha minus 5 sec squared alpha meters. Here's what's going on. For this question, there is no resistance. This is a 3US question, by the way, that you can get. Um, when you fire a ball upwards at an angle, right? Velocity is a vector quantity. So it has a vertical part, the part lifting me upwards, and a horizontal part. The vertical part is 20 sine alpha, and the horizontal part is 20 cos alpha, right? So we have two distinct parts. Now I'm gonna label this as y and x, okay? X horizontal, y is up, or whatever, right? So for y double dash is negative g. Okay? The acceleration on my y is the gravity, you get me? Which means that y dot is negative gt plus c1. When t is 0, y dash is equal to 20 sine theta, which equals to c1. So the equation of velocity is negative gt plus 20 sine alpha. And so y equals negative uh, gt squared on 2 plus 20t sine alpha plus c2. At t equals 0, y is 0, which tells you that c2 is 0. So my equation for like vertical displacement, so negative gt squared on 2 is the same as writing negative 5t squared, because g is 10, plus 20t sine alpha plus 0. Okay? Does that make sense? So
No.
I can integrate in this way, I'm pretty sure, for like these sorts of questions because it's very like chill, right? Um and three, you'll do it like this. You'll like rarely see the integral like that because it's a waste of time. For x, x double dot is 0. I have no horizontal acceleration. I'm not giving it any force. X dot is just c3. Um, when t is 0, my velocity is 20 cos alpha, which means that's equal to C3. So x dot is 20 cos alpha. And so x equals 20t cos alpha plus C4. T equals 0, x is 0, which means C4 is 0. And so x equals 20t cos alpha. Okay? That's what it makes sense, right? Because for my horizontal displacement, right, if I'm starting off with a horizontal speed of 20 cos alpha, right, and I have no more force, it's a constant velocity the whole way, right? So the amount I travel horizontally just depends on time, right? It's time times 20 cos alpha. Does that make sense? Okay. To show the wall, the ball hits the wall at height h equals 20 tan. The wall is first located 20 meters away. Okay. So at x equals 20, you have 20 equals 20 t cos alpha, which means t equals to sec alpha. Okay. Therefore, and at x equals 20, y equals to height, right? I'm at this point over here. So h equals -5. T is sec squared alpha plus 20. The sec is 1 on cos alpha. So 20 sine alpha on cos alpha. So that's tan, right? So this is -5 sec squared alpha plus 20 tan alpha. And that's how you get the equation for h. It's by solving simultaneous equations. Does that make sense? And
Mhm.
what you learn here will translate over to three projectile motion as well. Same thing. B, show that the diff of sec alpha is sec alpha tan alpha. Because you're not actually taught that the diff of sec alpha is sec alpha tan alpha. It's more of a 3D question. But the way you do it is sec alpha can be written as cos alpha to the power of -1. So you have -1 cos alpha to the power of -2. Diff of cos is negative sine alpha. And this is equal to sine alpha on sine alpha on cos alpha times 1 on cos alpha. That's just sec alpha times tan alpha. Right, so I'm done there. Hence, show that the maximum value of height occurs when tan alpha equals 2 and find this maximum height. Okay. H equals -5 sec squared alpha plus 20 tan alpha. DHD alpha equals -5 times 2 sec alpha to the power of 1 times sec alpha tan alpha. Diff of tan is 20 sec squared alpha. So now I have -10 sec squared alpha tan alpha plus 20 sec squared alpha equals, yep, that's it. And the max will occur when it's equal to 0, which means that um 10 sec squared alpha times 2 minus tan alpha equals 0. So the question is either sec alpha equals 0 or 2 minus tan alpha equals 0. Can sec alpha ever be 0?
Uh, so I mean, yes.
What is sec alpha? Fun.
So one.
One
Oh, one
on
plus tan squared. Oh, okay. When I was thinking it was like one over cos squared. So cos squared could equal 0, right?
cos squared can be 0, but 1 over 0 is infinity.
Oh, okay, okay.
Okay?
Oh,
So
okay.
it can't be
So
0.
it's one plus tan squared. So it
Yeah,
can't be.
it can't be. Yeah, good. That's another way to think about it. So therefore, because sec is never 0, implies that tan alpha equals 2. Okay? So this is where I have my max height.
Wait, but wouldn't you like have to
Show it.
solve the second derivative?
Correct. But you see how diffing it again is a bit annoying?
Yeah.
And like, it's alpha. It's not a value you can plug in simply, right? It's not clean. So what I would do to prove that it's maximum is I would have h d alpha here, right? And what I would do is just plug in alpha into DHD alpha. Oh no, this should be alpha. Right. So tan alpha is 2. So arctan of um 2 equals to, I'll turn it into radians. Oh, doesn't really matter. So this is about like at 63.43 degrees, it's 0. So I'm gonna test 60 degrees and 70 degrees, right? And when you put it into your calculator, you'll get positive to negative values. So that's
Mm.
a maximum point. Okay. So yeah, that's a good observation. You have to do this or second diff. I would prefer this because I don't want to diff again and then plug some stuff in, right? But up to you. I always do the table. So yeah, it's a max point here. And then find the maximum height when tan alpha equals 2. Okay. So as you pointed out, sec squared alpha is 1 plus tan squared alpha. So h equals -5 tan squared alpha plus 1 plus 20 tan alpha, which is -5 times 2, 4 plus 1 plus 20 times 2, which is 15 meters. That's the max height. And part D is find the speed and angle below the horizontal at which the ball hits the wall at the angle found in C. Okay. Um, so right now we're traveling at alpha. I'm gonna hit the wall, right? And at the wall, I have this is my velocity. That's my change in displacement over here, right? And the question is, how do I find the speed and how do I find the angle, right? I'm gonna ask you, what do you think?
Um, like for the angle, I'd get like the x and y components and then like divide
Good,
them together like
good,
10. And then for the speed, I just find the magnitude.
good, right? Now expand on the find the x and y components, right? Do you mean x and y or x dot and y dot?
I mean, oh, hmm. I mean, would it be normal x, normal y, or would it be uh, hmm,
For speed, right? Because
hmm,
velocity,
hmm.
you would need like the velocity
Okay, yeah.
x and y, yeah. So we need both components there. Um, and we have our equations, right? We know that y dot equals to negative gt plus 20 sine alpha. And then, bro, this big guy is like, is it worth joining if I haven't watched lesson two? He's so behind. Oh my God. Okay. Anyways, um, and then x dot is equal to 20 cos alpha. Okay. Uh, what is the time we spend? Okay, we spent sec alpha traveling. Okay. Tan alpha is 2. So we know a couple of facts. We know that time when we impact the wall is equal to sec alpha. And um, we also know that tan alpha equals 2. Okay. So we have, if tan alpha equals 2, right, I'll draw a graph out here. 2, 1, and root 5. Okay. Uh, so y dot is equal to uh 20. So sine alpha is equal to 2 on root 5, and cos alpha equal to 1 on root 5. So y dot now becomes 20 sine alpha, isn't it? So 20 times 2 on root 5 minus 10 times t. T is sec alpha, that's root 5. And this equals to 40 on root 5 minus 10 root 5, and that's negative 2 root 5. Something tricky. And for x dot, that's just equal to 20 cos alpha. That is 20 on root 5, which is 4 root 5. Okay. So I have my x and y components. I'm nearly done. Right now, I'm going down at 2 root 5, going across at 4 root 5. Speed is the magnitude of this vector over here. Therefore, this is going to be 4 root 5 squared plus 2 root 5 squared all square rooted, which is 80 plus 20 square root. And that's 10 meters per second. And then for my like angle, tan theta equals 2 1 root 5 on 4 root 5, which is a half, right? Therefore I am arctan of a half degrees below horizontal. You need direction because I could also be like above as well, right? Does that make sense?
Yeah.
The whole process? Okay, cool. Okay. A particle is projected from the origin O at speed v meters per second at angle alpha above the horizontal, landing at point P on a plane, inclined at beta to the horizontal, where beta is less than alpha, less than pi on 2. So we're given displacement equations. X is vt cos alpha, y is vt sine alpha minus half gt squared. If the particle strikes the plane at xy, show that x is equal to all that. So they've given us x in terms of y. This is interesting. If particle strikes the plane, okay, at xy. So we know what the equation of our, like, we know what the parametric equations are for my parabola, right? And I'm going to strike the plane. The plane, what kind of equation is the plane?
Uh, like linear. Like,
Linear. Yeah, it's a line, right? What's the equation of this line? You can figure it out right now.
uh, um,
Like, what is one point it passes
yeah.
through for sure?
So the gradient y on x. So it's like
You
y
sure it's
equals
one
what?
x?
Sorry,
Are you sure it's one x?
I said y on x.
Y on x equals to what?
Oh, so it's just y equals x.
Hmm. How'd you get y on x equals 1?
I said y equals x
How'd you get y equals x?
because okay, look at
Hmm.
the gradient
And
is
how do
y
you find a
on
gradient here?
x. Sorry.
So the gradient is y on x,
Yeah.
but how do you know it equals 1? That's my question.
Oh, hmm,
Look at
oh,
part A and look for any interesting terms that might clue you as to how to find a gradient.
part A. Five stripes point. X, Y, show that. Hmm. Oh, hmm, I'm not really sure.
So good. So y on x is your gradient, and that's y, that's x.
Hmm,
Angle beta is important here. Y on x is tan beta. So y equals tan beta x.
hmm.
Does that make sense?
Wait.
Because tan beta, the angle of my plane, right? That's the angle. That's just
Yeah,
y on x.
yeah. Oh,
So
yeah.
that's my gradient. It's y equals tan beta x.
Oh, okay.
Um, so I know
So
here,
tan beta equals
yeah,
one. How does it equal one though?
tan beta doesn't equal one.
You just said the gradient was one though.
No, you told me gradient was one. I was like, what's going on?
I was trying to prove the gradient was one.
Oh, I'm confused.
Dog.
It doesn't matter. Doesn't matter.
Okay. No, I
Fact.
got it. I got it.
Okay. X equals, so we know it's VT cos alpha, where V is the initial speed. y is negative gt squared on 2 plus vt sine alpha. And we also have y equals tan beta x. Okay. Um, vt cos alpha. And then we just plug it all in, right? Because we're solving these equations simultaneously for my um intersection point. So this implies that I have negative gt squared on 2 plus vt sine alpha equals tan beta times vt cos alpha. Okay. Um,
Mm.
and then I want to basically solve for at what time does impact occur, right? At what time does impact occur? I need time because my like task here is to find the x value. We know x is vt cos alpha. V isn't my answer. Cos alpha isn't my answer. T isn't. So I'm
Mm.
solving for t here. I will have let's take some stuff out. Vt minus gt squared. Okay, so therefore gt squared on 2 um plus vt tan beta cos alpha minus vt sine alpha equals 0. And note that obviously they meet when t equals 0 at the bottom of the plane, right?
Mm.
So t equals 0 is not a valid solution here. Say t not equals 0, like we want second solution. Therefore, gt on 2 plus v tan beta cos alpha minus v sine alpha equal to 0. And then we have just one t, so move everything to one side. Gt on 2 equals v times sine alpha minus tan beta cos alpha. So t equals 2v sine alpha minus cos alpha tan beta divided by g. Okay? That's and then that's time. We solve for time, but we know that x equals v times cos alpha times time. So it's 2v squared cos alpha sine alpha minus cos alpha tan beta on G. So I've solved for part A. Does that make sense?
No.
Okay. So it's simultaneous equations, right? It's a big jump from here to here, but this is a 3U question. This is a 4U question. Um, Most likely. Hence, show that the range R up the plane is this. Show the range R up the plane is that. This seems quite difficult, right? But what you want to understand is, I know a couple of facts. This is beta, this length is R, this is Y, and that's X, and this is 90 degrees. So method one, which is like brain dead, is you know X, right? Y equals X tan beta. So isn't R just the square root of X squared plus Y squared?
Mm.
But it's slow. A lot needs to be done. Alternatively, note that cos beta is X on R.
Mm.
So R is just X divided by cos beta. And you're done,
Mm.
right? So all I would have to do here is divide like X by cos beta, which is much quicker. Do you agree?
Yeah.
So that's the key strategy here. Um, X equals 2v squared cos alpha sine alpha minus cos alpha tan beta over g cos beta. What are they asking for though? But here they combined it all into sine alpha minus beta and cos squared beta. So what I want to do now is just try to get it into this form. So the first thing I want to do is like, okay, I'm gonna clear this stuff up. Cos sine alpha. Okay. I have a cos squared on the bottom, so I'm gonna times top and bottom by cos squared. So I have 2v squared cos alpha times sine alpha minus cos alpha tan beta. But then times it all by cos beta, right? So cos beta, and then I have g cos squared beta. Tan beta times cos beta is sine beta. I have 2v squared cos alpha sine alpha cos beta minus sine beta cos alpha over g cos squared beta. This gives me 2v squared cos alpha sine of alpha minus beta over g cos squared beta. And I'm finished.
Wait, did we get the wait? It's like the first first like part A. Wait,
Yes, we got part A. And the way you did part A was um I try
wait.
to solve for time,
Yeah, yeah.
right?
No, I remember, but wait. Show me what you got for A, because
Or like, did we get part A in the first place?
yeah.
Oh, um, yeah, you're right. I didn't do it like the way that they did it. Oh, so they basically like factored out the cos alpha. So they did this. Um, 2v squared cos squared alpha. So sine alpha divided by cos alpha is tan alpha. Cos
Mm.
alpha divided by cos alpha is, just one. So I just have my tan beta remaining on G. And that's my final answer. So all they did was they factored out cos alpha.
Oh, yeah. Okay.
Yeah,
Yeah.
good catch. I didn't see that, but yeah. To be fair, if I factor out cos alpha, I might not have seen this low key. It seems a bit whatever, but yeah, that's a strategy. Okay, does that make sense?
Yeah.
Okay, part C. Use the identity 2 sine alpha cos beta equals to or that to show that the maximum range up the plane R max equals to this. The maximum range. Sure. I see this. Okay. 2 sine alpha. Copy this. Ah, suck. So we know that 2 sine alpha cos beta equals, or sine AB equals sine of A plus B plus sine of A minus B. Now, I'm not thinking back to my previous equation for range. How use this formula at all, right? What do you think, looking at the previous question?
Oh,
Where would I use this?
oh, you times cos theta by sin sin theta minus beta.
Exactly right. So in this case, I might like swap it around to make it clearer. I have sine alpha minus beta and cos alpha, right?
Mm.
Here it now becomes 2 sine alpha minus beta cos alpha equals sine of 2 alpha minus beta plus sine of negative beta.
Mm.
Like, yeah. Um, Therefore this R becomes V squared times sine of 2 alpha minus beta minus sine beta over G cos squared beta. The minus came out because it's an odd function. That's why. So yeah. Mm, and when does the max occur? So I'm gonna say a couple of things here, right? Alpha can change, beta is a constant. Does that make sense?
Uh, I'm feeling weird. Oh, yeah, yeah, yeah.
Yep. Okay, we're trying to figure out like when the max occurs relative to beta. And the way you clue that is because here I start off with alpha. At the end, I have no more alpha. So what we're doing is finding max at where, like max for alpha. You get me? So the
Wait,
one approach is to
say it
diff.
again. Sorry, say it again.
So like for R, for the range, right?
Mm,
I have alpha in my equation, but for
mm,
the max, I have no more alpha.
mm,
That implies that I've already found the value for alpha at which it's maximized.
okay.
Alpha is changing.
Mm,
One approach is to diff it. But I think a smarter approach is that R is max when sine of 2 alpha minus beta is maxed. Because literally everything else here is a constant term, right? Maximizing R just means maximizing the only term that can change. You get me? So
uh,
sine 2 alpha minus beta, what's the max value for that?
one.
Yes. So 2 alpha minus beta must be equal to pi on 2,
Mm,
right? Therefore, R max equals V squared 1 minus sine B over G cos squared beta. We're nearly there. Their answer has no 1 minus sine B on top, but they have a 1 plus sine B on the bottom. What do they do?
times like times it by like uh like kind of rationalize it.
Yep. Walk me through it.
So you times it by one plus sine beta.
Yes. So you get 1 minus sine squared beta on top of G cos squared beta times 1 plus sine beta. What's next?
You'd expand. You make cos squared beta equal one plus sine squared beta.
Cos squared beta is 1 minus sine squared
Oh,
beta.
sorry, one minus sine squared beta.
So, yep, and this cancels out.
Yeah.
And boom, you have V squared on G, 1 plus sine beta.
Mm.
So whenever you have a messy trig, often there is no need to diff, right? Like you could have tried diffing, but there's no need. Just look, try making an observation like that. If beta equals 14 degrees, find the angle alpha at which the particles should be projected to reach maximum range. They told us beta is 14 degrees. What should alpha be? You know this, by the way.
Two alpha minus beta equals pi on two. So
Okay. So 2 alpha equals 104 degrees, and alpha must be 52 degrees.
yeah.
Right. Cool. So that's a equation involving an inclined plane.
Mm,
So you can imagine how tricky it would get if you have an inclined plane with resistance and all of that, right?
yeah.
Okay. A building stands on level ground. The nozzle of a water sprinkler is at point P on the ground. Um, Distance D from a flat wall of the building. Water sprays from the nozzle at speed V, and the nozzle can be pointed in any direction from P. Okay. The idea here is that, this nozzle is varying. It can like land on any of these points. Max is 15D on 8 height, but also it can be pointed in any direction. So if I look at it on like a 3D scale, it's not a 3D problem, by the way. Just like you don't need 3D, but like have a look. It's like this. This is my like wall over here. And then my nozzle can, hit the wall here, hit the wall here, or go in like this direction over there. Wait, it's in, you can go there, you can go there, go there, and go there. Or you go
Mm,
over like here or whatever, right? So it makes sense. I can rotate it around the origin like that. Like
mm.
this. Yeah, that's what's happening. So if V is greater than GD, prove that the water can reach the wall above ground level. The water can reach the wall above ground level. What this is telling me here is that um I need enough velocity such that my max range isn't limited to D. Okay? So
Wait,
yes,
I don't really get what the question's asking.
the question isn't okay, this part is just telling you what's happening.
Yeah,
Yeah.
yeah. No, no, like A, like part A.
Hey, what this is asking us is that basically if your nozzle isn't fast and isn't quick enough, right? Your range is limited to here. So I never
Yeah,
get one in the first place, right?
yeah.
What we're
So
trying to figure out is how fast we have to go to at least hit the wall.
okay, sure.
Yeah. Now, from before, I'm gonna like rewrite the motion equations. I'm not deriving anything. So we have initial velocity is v. So we have x dot dot is 0, x dot is v cos theta, and x double dot is vt cos theta. Y dot is negative g, y dot is v sine theta minus gt, y dot dot is negative gt squared on 2 plus vt sine theta. Any issues with these?
No.
Okay, just from previous derivation. So we want our range to be at least like d, right? Um Now the range occurs when you finally return back to the ground. Does that make sense? So range is when I return back to ground. I return to ground. At the ground level, my y value is 0. Therefore, y equals 0, implying negative gt squared on 2 plus vt sine theta equals 0. When t equals to 0, I'm at the initial points, right? So I'm going to say, assume here, t is not equal to 0. Therefore, negative gt on 2 plus v sine theta equals 0. And so t equals to 2v sine theta divided by g. Okay? So at this particular time, I'm going to return back to ground level. That's where I can figure out how far I traveled horizontally. That's the first step. Does that make sense?
Yeah.
Now, once we know what the time is, we have to plug it back in. So x equals to v cos theta times t, which is 2 v squared sine theta cos theta divided by g. Okay. So we have the value for x now. And we want x to be greater than d. We want
Wait,
x,
why is X V cos theta?
uh, x is v cos theta times time. That's my displacement
Oh, okay, yeah.
yeah. Like initial velocity times time, right? Like
Yeah,
normal
yeah.
speed.
Yeah.
Okay, we have this so far. Um 2v sine theta. Okay. And then the idea here is that 2 sine theta cos theta now becomes um v squared sine of 2 theta on g is greater than d, right? So v squared sine of 2 theta is greater than gd. So v squared is greater than v squared sine of 2 theta, which is greater than gd, because sine 2 theta is equal to 1 or less than 1. Make sense?
Mm.
And so v squared is, or therefore v is greater than the square root of gd. Does that make sense?
Wait, so wait, why is 2V squared sine theta cos theta over G bigger than D?
Because
Oh,
I
that's our
want my
assumption.
range to be beyond the wall.
Yeah, yeah.
Because
Okay.
if I come back to 0 at D itself, I'm on ground
Mm.
level. But if I land a little bit further, you see how I pass the wall now?
Mm, okay, okay.
That's the idea. So I must at least To hit the wall, my max range should at least be where the wall is situated. Okay. Is that clear?
Yeah.
Okay. Suppose V equal to 2 square root 2G. Okay, 2 square root GD. Show that the portion of the wall that can be sprayed is a parabolic segment of height 15D on 8 and area 5 root 15 on 2D squared. Okay, this is where it gets hectic. This is, I think, the last question of a Cambridge question, a chapter. Here's what this is trying to tell us to visualize, right? So again, I have my wall, and when I spray it, the wall doesn't go in any particular direction, right? As I keep spraying it or whatever, on the wall, I get this pattern. That is the maximum amount I can cover in water.
Mm.
Okay. And it's on a circle, it's a parabolic segment. Imagine a concave down parabola in 3D.
Mm. Okay.
That's what it's asking us to find this area over here. So that means some integration will also be involved, right?
Mm.
So yeah. So the vehicles to okay. So let's see how we go about doing this. Um show the portion of the wall that can be sprayed is a parabolic segment of line. Well, for here, I think all we care about is the position of each of my dots. So I just care about displacement equations. So let me just like copy these. What the heck? Okay. And all of these points, so this distance here is um like D. Okay. Portion of the wall that can be sprayed is a parabolic. Mhm. I want to make a couple of observations. The
Mm.
first one here is that regardless of where I'm pointing at, I'm going to be some distance, like capital D away.
Mm.
That's the first observation. The next thing I want to observe here is the edge, the edge of this parabola is the maximum value for y. Does that make sense? Because obviously, if there was a greater max, then it would be above, right? But
So
because
the
it isn't
parabola is kind of going like up like that.
like this,
Yeah, like how do I explain it? Like it's not like flat, it's like going up. The parabola.
what do you mean it's going up?
As in like it's not like oh no, it's fine.
No, no,
No.
fine.
Like okay, what I was trying to say, it's like not just on the XY plane, it's just like it's like going like the parabola is not just flat, it's like going up. So that's why. Like do you know what I mean?
Kind of. I'll try to
It's
graph it
like
in 3D for you.
hmm?
I'll try to graph it in 3D.
Oh, no, but I get why it's the max.
Oh, okay. Yes. If you get it, then
Yeah.
sure. Okay. So let's move it down. So it's a max, right? So because it's the furthest you can reach, right? That's the first one I want to make here. So it travels D and we don't care about all these points in between. That makes my life confusing. I care about the outer edge. That edge is my parabola. Okay. So when x equals to some distance D, I want to find the max value of y. Okay. The max value of y. So we have x equals to u, not u to v. We have vt cos theta. This tells me that t equals to, um, I know, but then x equals d, that's my distance. So distance equals vt cos theta. And so t equals d over v cos theta. If I plug this into my equation for y is equal to negative g d squared on 2 cos squared theta, no, on 2 v squared cos squared theta plus um vt plus dv sine theta on v cos theta. I'm gonna plug it in. So I have negative gd squared 2v squared sec squared theta plus d tan theta. I have negative gd squared 2v squared 1 plus tan squared theta plus d tan theta. Okay. So I've simultaneously combined them like parametrics, right? Okay. I got rid of t by finding t in terms of like my x value. Then I told you we want to maximize this. We want to maximize what our y value. Let tan theta be equal to t. dy dt equals to negative gd squared 2v squared um times 2t, I believe. Over 2v squared. Yeah, 2v squared times 2t plus diff of dt is d. And another like thing we can do here is note that we're given velocity. Velocity is 2 root gd. So I have negative g d squared on that's 8 gd times 2t plus d. Cancels, cancels. Times 2t. Negative negative d. Negative d. Um negative dt on 4 plus d. I think that's what it simplifies to, if I'm not mistaken.
Did you diff it wrong?
Did I?
'Cause, uh,
Wait, maybe I think my diff is correct. I think it's correct.
what? Oh, wait. One plus
But
two
like
is what?
I plugged in I think I plugged in the wrong value because velocity is 2 g small d. It's not the yeah, it's this value here. It's not like this general distance value I created for myself, right? Um so it should be 8 GD, and that simplifies to negative um d squared t on 4d plus d. Okay, we want this to be equal to 0. And so this means that t must be equal to 4 lowercase d on d, right? Um, extra page. I can double diff it again. So d squared y dt squared equals to negative d squared on 4d. That is less than 0 all the time, which means that t is max at 4d on d. So I'm not going to go back to my y value. So the equation for y max is negative g d squared. 2 times v squared is 2 square root gd squared. T squared is 1 plus 16 d squared on capital D squared plus capital D times 4d on capital D. I have negative g d squared on 8g lowercase d plus 4d. And now I just have to like simplify all of this. So what do I get here? Oh, okay. So this be negative g, this cancels. Negative d squared on 8d plus minus 2d squared minus 2d plus 4d. So it's 2d minus d squared on 8d. Okay. So what we've done here, right? We created a new variable called distance to the wall, right? Um, then we solved y and x simultaneously when x equals the distance to the wall. I found this equation for y. I diffed it to figure out when is my value maxed for y. And then I plugged it back in and got this equation here. This is the outer edge. It looks very parabolic. The reason is that d is just a constant. It's the capital D that's changing. This is a concave down parabola. Do you see that?
Mm.
Okay, cool. So what we are nearly done, right? And then I can try to like graph this out. So when d equals to 0, right? I have this is 15d on 8. And then we want this to be equal to like uh 0 for my x-intercepts. So 2d minus d squared on 8d equals 0. This means that d squared on 8d equal to 2d. So 7, right? D squared on 8d. What am I doing here? What's the last step? One step when d is 0. Ah, track back. Draw the 3D plane again. Outer edge. Right. Y max is 2d minus d squared and 8d, right? To find this point, the height of my parabola, that is when my distance d is lowercase d, right? So here, height is when capital D equals d. So the height equals 2d minus d squared on 8d. That is 2d minus d on 8, which is 15d on 8. Okay. The next part is how do I know what these values are? So when this is D, like capital D, right? I have my sort of x coordinate. So I want to find an equation for y in terms of this x value. Okay. So we know that d squared equals x squared plus lowercase d squared. So now I have y max equals 2d minus x squared plus d squared on 8d. And now I can soon begin integrating. So I'd simplify this. I now have 15d on 8 minus x squared on 8d. So up until this point, right? Like ignoring this stuff below, are you on board?
Yeah.
And then now that, okay, so you see, I can't integrate with D. It's at an angle. I want to integrate on the surface with some x coordinate here. My equation is in terms of D, but I want the x value, right? So I figured out a way to convert D into x squared plus D squared. Does that make sense?
Mm.
Okay. And then let's start integrating. So 15D on 8 minus x squared on 8D equals 0 means that x squared on 8D equals 15D on 8. Cancels, cancels. X squared equals 15D squared. So x is D root 15. Okay. D root 15 negative and D root 15 positive. Or it should be plus or minus. Then the integral is going to be from negative D root 15 to D root 15 of 15D on 8 minus x squared on 8D with respect to x, because x is changing. And this gives you 5 root 15 on 2 d squared once you simplify.
Mm.
So that's the hardest question I've ever seen, like in my life, for this like concept. So for like
Mm.
normal projectile motion, right? This is the absolute ceiling, but even then I wouldn't expect it. But what I do want you to understand is like part A, I think is a very standard question. So range. Range is when y is again 0. I finally landed back. Find the time at which you land back again, and then find the how far you traveled. For that's what
Wait, could you kind of like run me through A briefly again?
yeah. So for A,
Mm.
the question was asking us, when will I ever reach ground level? Okay, or like above ground level.
Mm.
So if my max possible distance takes me to the bottom of the wall, I can't hit the
Mm.
wall, can I? So I need to ensure that my max possible range is at least D,
Mm.
at least D. So the
Yeah.
question is, how do we find the range? The way you find range is, note that when you land back on the ground, your Y value is again 0.
Mm.
So I've let the displacement for Y be equal to 0.
Yeah.
I know the time can't be 0 because that's like the initial point when y was 0 in the first place. Then I found t is 2v sine theta on g.
Mm.
Now it ranges horizontal distance, right?
Yeah.
So knowing what time is means I plug in that value for time into x,
Into X, yeah.
and that gives me this equation over here.
And how do we know that's bigger than G?
Well, we don't, but we want it to be bigger than d. So we
Okay.
say here, okay, range is v squared sine 2 theta on g. We need v squared sine theta on g to be bigger than d. It doesn't have to be. It can be smaller, but we want it to be. So
So we're
if
just assuming it is.
because the question is how like you know at what value for v can it be bigger than d? Does that make sense?
Mm. Yeah.
Yeah. Uh bro, I'm is joining now.
Uh,
Wait a minute. The first half, it's all being recorded, by the way. I think it'll be
oh,
worth it to
okay.
look at. But we're about to start like resisted soon as well. So you're on time for the second half. But first half's about to
Oh,
it's
okay.
recorded. Okay, so I got you.
Yeah.
Yeah, so we want yeah, so basically the question isn't like will it ever reach like oh like why is it always greater than D? That's not the question. The question is if I want it to be greater than D, how fast must I hit my projectile? Does that make sense?
Okay. Yeah. Yeah.
So then, okay, this has to be greater than d. So v squared is greater than gd on sine 2 theta, and that's greater than gd. So v is greater than square root of gd. And that works.
Mm.
And then for the parabolic part,
Yeah.
it's tougher because I can move around. So I have variable distance d. So we create a new variable d. I'll let x be d, a new variable. I solve it simultaneously one more time, right? So to find out each like coordinate, And so this is all the possible values for y, all the possible values for y, right? After I travel d. So this equation is showing me every value here, okay? But we don't want every value. We want the outer edge. So to maximize it, I diff the equation with respect to t, where t represents tan, and I solve that t is 4d on d, and we use double diff to prove that it's max.
Mm.
I plug it back in. I simplify to get this is the equation, right?
Is that the equation of the parabola?
This is the equation of the parabola, yes.
Yes.
But
Okay.
it's not in terms of like, x. It's in terms of capital D. You get me?
Mm.
How do you
Yeah.
integrate at like an angle? It's a bit weird.
Mm.
So we turn capital D into x and my constant D because it's x plus D squared. Then I'm like, okay, sure, plug it in. You get this new equation to x, find your x-intercepts, and then you integrate.
Yeah. Good.
And that's it.
Yeah.
But it's a very full-on question, so you might find it helpful to go back in the recording for this one. Have you seen it before? It's in Cambridge.
Uh, I don't think so.
Last question on Cambridge, I think. It's annoying. Okay. Um, so 542. We resisted in motion. I'm gonna get some water and we'll keep powering on onto resistive motion. So that Bond can leave by like 6:30, I think.
Yeah.
Yeah. Um, but here, after we're done, I'll give you a summary of what we covered beforehand. Have you done 3U um
Yeah, yeah.
motion?
Projective motion. Yeah, yeah.
Yeah, okay. So the first question was like a lot of that, and then we have it on an inclined plane. Have you done this sort of question before?
Yeah. I actually have questions similar to this in between. I'll do an incline.
Okay. Can you give me a rundown of that later on? And then we have this meshed question. Yeah. Okay. All right. This makes me mad, this question. There's just so much going on. Right. This is like a boring derivation question. Here's a good thing though. You know how for like horizontal and vertical questions, you can have velocity proportional to like v squared, right? Sorry,
Mm.
resistance proportional to v squared. You
Mm.
can't for projectile motion because if you have it proportional to v squared, um when you try to like separate into its vertical and horizontal components, you get an impossible diff that you can't solve with like 4U methods, right? Like you can't integrate it at all. So that as a result, the good part about resistive projectile motion is that you don't have proportional to v squared. It's just like v most of the times, right? So it's very chill. Um, a particle is projected with this speed at angle alpha. Um, Air resistance is proportional to velocity, right? So it's going to be like, you know, K per unit mass. So the horizontal resistance is negative K x dot, and the vertical resistance is negative G minus K y dot, right? So x dot is the velocity, so it's proportional to velocity, it's minus because it's resistance. For y double dot, it's negative G minus K y dot because you have gravity as well as resistance. Is that clear? Okay. Show that x dot, so okay. X dot dot equals negative k x dot. So we have d x dot dt equals negative k, negative k x dot, dx dot x equals negative k dt. So ln x dot equals negative kt plus c. Um, and so you have apps value is equal to e to the power of c times e to the power of negative kt. X dot equals plus or minus e to the power of c times e to the power of negative kt. Question is, what is this term? So I'm predicted with the velocity of v at angle A. So my horizontal is v cos alpha. Okay? At time equals 0, x dot is v cos alpha, which is equal to plus or minus EC, right? Therefore, x dot equals v cos alpha e to the power of negative kt. Does that make sense?
Mm.
And it totally makes sense, right? Because we saw in like the without resistance, it's v cos alpha, but then there's exponential decay because over time it gets slower and slower because e to the power negative kt, right? For y double dot, so we have y double dot equals negative g minus k dot ky dot y dot, so dy dot over g plus ky dot equals dt, negative dt. 1 on k ln g plus ky dot equals negative t plus c2. So ln this equals to negative kt plus kc2. G plus ky equals e to the power of negative kt times e to the negative kc2. Like this is a drudge, but you'll do this like so many times in mechanics, right? Um, Also, it's very high yield because your last question of the HGC, it will probably involve a mechanics question, right? You'll see it in most trials. Um, and then you'll get y equals negative g on k plus or minus e to the power of kc on 2 on k e to the negative kt. When t equals 0, at t equals 0, y equals to, so y dot is equal to v sine alpha. So v sine alpha equals negative g on k plus or minus e k c2 on k times 1. So plus or minus this like very ugly term is v sine alpha plus g on k. So I plug it back in now and I get y dot equals negative g on k plus v sine alpha plus g on k e to the power of negative kt. And then if you like move it around and like factorize, you get this. Okay? So that's my bit of a step up from the 3U style projectile motion. And then you integrate this, so you want each of these one more time. So x now becomes just v cos alpha over negative k e to the power of negative kt plus c3. And then at t equals to 1, or 0, sorry, x equals 0. So 0 equals v cos alpha negative k plus c3. C3 is v cos alpha on minus k on k. X is v cos alpha on k minus v cos alpha on k e minus kt. So that's the first part of part B. And then for like y is just If I integrate this one more time, it's negative gt on k minus 1 on k v sine theta plus g on k e to the power of negative kt plus c4. So at t equals 0, y equals 0, so 0 equals 0 minus 1 on k v sine theta plus g on k plus c4. C4 is all of this. And so y equals negative gt on k plus 1 on k v sine theta plus g on k times 1 minus e to the power of negative kt. Drag. Do I have the k squared? Yeah, it's fine. That's part B. So all of that was just integration. So was that clear to everyone? Okay. Show the particle reaches its greatest height when time equals to all of this. So guys, what's the condition to reach greatest height?
Velocity equals 0.
Yeah, but velocity was for like mechanics.
Oh, that's not.
So which
Oh.
part? So which one? Which velocity? Because there's two now. There's horizontal and vertical.
Oh. Like
Right.
it'd be vertical.
Vertical, yeah. I went up, just stop here, and come down.
Yeah.
So uh y dot equals 0, implying that negative g on k plus v sine theta plus g on k e to the power of negative kt equals 0. Yeah, and then do I have an ln here? I have an ln. V sine theta plus g on k e negative kt equals g on k. Then vk sine theta plus g. And then negative kt equals to ln this. And I don't need absolute value. T equals 1 on k. Move the negative inside so it flips. So vk sine theta plus g on g. And that should be my answer. Yeah. Okay. Hence, show that the horizontal distance traveled when the particle reaches its greatest height is this. Boron, how do I do that? How do I find the horizontal distance traveled when the particle reaches its greatest height is this?
Mm, so we know what T is, and we just sub that into horizontal displacement.
We know what T is. Yep, that's exactly correct. Where is my horizontal displacement? Yes, yes. So uh that's just normal x. X equals v cos alpha times e to the power of negative kt. This is my time over here. Oh, it's the wrong side around. Yep. So times both sides by negative k, right? And I'm going to get negative kt equals to ln g on vk sine theta plus g, because the negative went to flipping the inside. E to the power of negative kt is g on vk sine theta plus g. So x is now equal to vg cos alpha on vk sine theta plus g. So, but for some reason, there is a sine 2 alpha. I'm trying to figure out where that came from. And I know where it came from. It's because I used the wrong equation. Bro, I used it for like velocity. It should have been for like displacement, shouldn't it? Yep, hold up. Copy. paste. Most of it's reusable though. So x equals to v cos alpha on k minus v cos alpha on k times g on vk sine theta plus g. And it's not theta, it's alpha. Same thing. Now to combine it. So let's factor out the v cos alpha on k. And then I'm going to get v cos alpha on k times vk sine alpha plus g minus g on vk sine. Oh, I see it now. Cancels. You get v squared, um, k sine alpha cos alpha on vk squared, sine alpha. No. K times vk sine alpha plus g. Um, they combine the top part into double angle, right? So you times by 2, cancel these two. I v squared sine 2 alpha on vk sine alpha plus g. And that's my horizontal distance. Okay, cool. I'm done with that. And part E is show that the Cartesian equation is the following. Okay. How would I find the Cartesian equation given that I know what my like 6 motion equations are? What do you guys reckon? Am I here?
Oh, in X, like you make A minus KT in terms of like everything else, and you sub that in maybe.
Yeah, that's it, right? Good. So she's not a nice thing to do. It's very annoying. So we know that like we know x is equal to uh what's x equal to? V cos alpha on k times 1 minus e to the power of negative kt, which means that 1 minus e to the power of negative kt is yeah, it's kx on v cos alpha. And so e to the power of negative kt is 1 minus all of this. And then we know t would be equal to 1 on negative k ln 1 minus kx on v cos alpha. And then we know y is all that. So you just plug this into here and then this over here and then simplify. And that's it. Does that make sense? It's just like, parametric equations, right?
Mm.
So no need to go through it. Yeah. Okay. So the last two questions, right? Because we literally just derived all the formulas for the 6 motion equations. Do you guys have any questions with that? Or were you fine with it? The derivation.
That's fine.
It's fine, right? Because for the next question here, the first question is like, oh, derive this. So we have a ball being thrown from a tall building. It experiences a resistance proportional to velocity. It's the same equations as before. And so they want us to find out the velocity and the velocity for x and velocity for y. But we've just proven that in the previous question. So I'm going to skip over part 1 and 2. Find the value of t when the particle reaches its maximum height. So again, that's when y dash equals to 0, right? Same question as before. So when y dash equals 0, this means that ku sine alpha plus g e to the power of negative kt minus g equals 0. And so the time to max height is 1 on k, ln 1 plus ku sine alpha on g. Okay, that's it. And part 4 is what is the limiting value of the horizontal displacement of the particle? Okay, so this one we'd actually have to find out what my displacement is. So if x dot is u times e to the power of negative kt cos alpha, then x is equal to negative u on k e to the power of negative kt cos alpha plus like c. And at t equals 0, x equals to, well, x is u cos alpha. So u cos alpha equals to, yeah, negative u on k cos alpha plus c. I don't know why I thought I did something wrong. Am I right? A time equals 0. Oh, I'm dumb. It's displacement. A time equals 0. I'm at the starting point. I'm at 0. So c is u on k cos alpha. And that means that x equals u on k cos alpha times 1 minus e to the power of negative kt. So now that I have my equation for horizontal displacement, how would I find the limiting value for it?
Like as t like approaches infinity, e approaches 0. So like that thing approaches 0. So it's just gonna be v on k cos alpha.
Good. U on k cos alpha. Nice. Cool. Here's the last question. This is a hard one. Okay. So we have a bit of time for it. A 100-gram football. Okay, 100 gram. What is a uniform mass for F equals ma?
Kilograms.
Okay, careful here. It's kicked from the origin O up a slope with the equation 2y minus x equals 0. It is subject to gravity, 10 meters per second squared, air resistance, negative 0.02 v, where v is the velocity vector. The football is launched at a speed 25 root 2 at 45 degrees to the horizontal. The acceleration is the following. Okay. And you have to show that this is the vertical displacement. You're given this, find the Cartesian equation, and then find part 3. How do I interpret, because before we just given you, oh yeah, x double dot and y double dot equal to whatever. It's given to me as a vector. How do I interpret this? But here, help me out, because you haven't been talking too much.
Uh, can you split it
Yes.
into I and J?
You can split it into I and J. That is right. But I think even more simply, acceleration vector is just your I component is just x double dot and y, and your j component is y double dot. You get me? So I have x double dot y double dot equals negative 0.10 minus 0.2 velocity vector is x dot y dot. Does that make sense, guys? I don't think I've really covered this one, but your like displacement is just your x and y. Your velocity is your x dot y dot, and your what's it called again? Acceleration is x double dot y double dot. So when you talk about your velocity vector, like here, it has two vectors. One vector, not two vectors, but like two um components, right? Does that make sense? What's going on? So it's all split up. So from here, x double dot is just negative 0.2 x dot. Before we had a k is some constant, now it's 0.2. And we have y double dot equals negative 10 minus 0.2 y dot. Those are your motion equations. So if you guys get your acceleration as like a vector, it can be decomposed into its parts. Does that make sense? Okay, cool. And remember that these by themselves are not vectors, they're magnitudes. Combine them together, you get the vector. Okay? That's what's going on. So you guys try out the next three questions. I'll stop you at like 6:20. Yeah. Were you guys able to do part one?
Yeah.
Nice. I'm here as well. Part two.
Mm.
Okay, I'm here you.
I'm still doing part.
Nice, nice. I'm here. You got part two.
Oh yeah.
Nice. Boring part. You got part two?
Yeah.
Yeah. Part three, what guys? You got that as well? No? What do you guys think the intuition is though? You want to find the range of the slope. We found the Cartesian equation for like the vertical displacement and like horizontal displacement combined, right?
Mm.
So range of the slope, what does that imply? What does that imply? Like most fundamentally, right? I'm going to intersect with the slope. Okay? And the equation of the slope is 2y minus x equals 0.
Mm.
Right. I.e. here, it's going to be y equals to x divided by 2. Okay? Y equals x on 2. So I have 3x plus 250 ln 1 minus x on 125 equals to x on 2. And then when you rearrange all of this, you get x plus 100 ln 1 minus x on a 125 equals 0. Wait, 100? Yes, 100. So that's what we are given, right? Do you guys get to this point over here?
Oh, no, but
Okay. So all we have to do was like combine it together. And now we have like this curve over here, right? Um, because what do I want to do here? X minus 1 plus x. Okay. So here we were given this curve where it's satisfied. When y equals to 5. So this mean like some key point, like I don't know, like x, like bar, right? When y equals 5, 5 equals 4 ln 1 plus x bar on x bar, right? So we have ln 1 plus x bar on x bar equals to 5 on 4. Let's just sort of get it into this position, right? So I have 100 ln 1 minus, okay, 125 minus x on 125 equals to negative x. And so ln of 125 minus x on 125 equals to on x equals to negative 100. This is not a negative number, so let's move the negative inside over here. So maybe like ln of 125 on 125 minus x on x equals to 1 on 100. There's a 5 on 4 involved. So then if we times both sides by 125, you get ln 125 on 125 minus x over 125 equals 5 on 4. Sort of nearly there. And then this part here has to be like 1 plus something, like 1 plus x, right? So if I take out a 1, I have here ln of 1 plus. This looks like 1 plus x on 125 minus x seems to work over um x on 125 equals to 5 on 4. So I think I'm getting somewhere, perhaps. Um, u plus 1 plus 5 on x. Find the range up the slope. Okay. Okay, negative 0.3. They're going stuck. I need to think. 1 minus x. 125 minus x. I think I'm just like I'm literally there. What am I doing wrong? Oh, maybe I know what. Let's like erase all of this. So let's try again. 100 ln 1 minus x on 125 equals to 0. Um, yes. Oh, equals to negative x, sorry. So ln of 1 minus x on 125 divided by x equals to negative 1 on 100. And if I times both sides by 125, which is negative 5 on 4, then I have ln of 1 minus x on 125 over negative x on 125 equals to 5 on 4. What I did here was 125 came down, negative went down over here as well. And this is equal to ln of 1 plus x bar over x bar equals 5 on 4 from the graph here, where x bar is just negative x on 125. Now, this was true when the x value is negative 0.37137. So negative 0.37137 is negative x times 125. So x is 125 times all of that, which is 46.42125 meters. And then we know that well, first of all, I think me and Boron covered this, right? Until Mahir came like an hour later, which was if this is some angle, right? I don't know what angle it is, like angle phi, right? And this is x. The range up the plane, so note that cos of phi is x on r. So r equals x on cos phi. Does that make sense, Mahir?
Yeah.
Yeah, so let's find cos phi. So if this so x y equals x on 2, this is x on 2, that's x, right? That means tan of phi is a half. That's the gradient, right? And so phi is like, okay, so if tan of phi is a half, that's 1 and 2, that's root 5. Cos phi is 2 on root 5. Okay? So that means that the range is x over 2 on root 5. That's about 51.9 meters, which is the correct answer for range. Does that make sense? Mahir, Boran, all good?
Yep.
Okay, cool. That's it for today's lesson. Boran, you gotta go now, right? So
Yeah.
yeah, I was like, tell Mahir what we did in the first hour. So Mahir, what we did was,
Yeah.
so Boran, we had a question about projectile motion in which like a ball is thrown which hits the wall, right? I'm gonna one the Okay, that's a mom. Sorry. Yeah. And the idea was the wall is 20 meters away, right? So because the wall is 20 meters away, I gotta figure out how long it takes horizontally to travel 20 meters. Okay, that's what I did. So x is 20, my displacement is 20, right? So I figure out time is sec alpha, right? And then I'm like, okay, how do you find the height? Well, just plug in the time it takes me to get to the wall and plug it into my y value, right? So I found the height. I showed the diff of this is sec alpha tan alpha using the fact that sec is 1 on cos, and we know how to diff cos. The max value of h occurs when tan alpha equals 2. So we found what h is. You diff it with respect to alpha, and you get this equation over here. Sec squared is never 0, which means 2 minus tan alpha must be 0. Tan alpha is 2. You do a little table of values to prove that is a max point. And finally, for speed and angle, so to find the angle below horizontal, you don't look at displacement, you look at the velocity. That's your position, right? So you find you find your velocity vector when x is 20 meters ahead, then theta is the angle between your velocity vectors. Okay. Again, you can get this more in depth over the on the video. We did like we covered here that the angle, the gradient of a slope is just tan of the inclination, right? Tan beta is the gradient. Does that make sense? Intuitively?
Yeah.
Okay. Um, and then so what we did for this question here was to find out the point at which I lie on a plane, I first solve for the Cartesian equation, right, of my projectile simultaneously. And then I plug in y equals tan beta x, and you get this equation. The range occurs, um, when does the range occur? What do we say here? Oh, if you know what point this is, right? This is the horizontal like coordinate. We didn't call it a range, it's just x over cos beta. So if you apply this to the first part, you get part B. Okay. And then part C was simplification. But to find max range, what we did was from the question, the clue, we used we expanded using like we turned the range formula cos A sine A minus beta into the sum of two trig functions over here. The sum of two trig functions. Okay, using this formula. And then we figured out that, okay, to maximize R, the only variable I'm changing is alpha. Beta is constant, velocity is constant, G is constant. I'm only changing alpha. So to maximize R, I have to maximize sine 2 alpha minus beta. That is max when sine is 1. So 2 alpha minus beta is pi on 2. And then if it's pi on 2, this is 1. So R max is 1 minus sine B on G cos squared beta. Cos squared beta is 1 minus sine squared beta. Divide it, you get this expression. Okay? Does that make sense? The logic there, sort of? Again, you can go back to the video.
Yeah.
Okay. This question, I would just say, watch the video. It's cooked. Genuinely
Okay.
munted. But yeah, like, have you had your English exam? Because is that why you are like a bit busy?
Yeah, so I'll have it tomorrow.
Oh, okay, no, fair enough. Yeah. Then watch the video like after like whenever you're free then. Yeah.
All right.
Don't worry so much about it.